Dear students, in this lesson we're going to cover the topic of indices. This is another section in algebra, a very important section, and we're going to see which are the index rules and how to apply these rules. So, indices. First of all, there are 6 laws of indices. We're going to demonstrate them all, show examples. We're going to learn them, but first, how do I write a number in index form? Mela, a number in index form is written as a to the power of n, where a is called the base and n is called the index or power. For example, 2 to the power of 5. This has a base of 2 and an index or power of 5. Now, what does 2 to the power of 5 mean? 2 to the power of 5 means 2 multiplied by itself 5 times. So that's index form. That's how we write a number in index form. Now, when we have these numbers in index form, we can work we can use them, we can work with them, and there are some laws which we have to know and understand and use in order to facilitate our work. So let's start with the laws. Law number 1. Law number 1 states that when multiplying numbers with same base, we add the powers. What's important? This is the most important part. First of all, we need to be multiplying and the numbers should be same base. Alright? In that case, we add the powers. Okay, so let's see a few examples. For example, 2 to the power of 5, we have already seen what that means, multiplied by 2 to the power of 3, that's 2 to the power of 5 plus 3, which becomes 2 to the power of 8. Another example, x to the power of 4 multiplied by x to the power of 5, that's same base x, so x to the power of 4 plus 5, which gives x to the power of 9. Another example, a to the power of m multiplied by a to the power of n. As we can see in this example, the indices are in algebraic form, they are letters, they are variables. So, since we have same base, that's a to the power of m plus n. And that is the answer to that question. Even if we have negative numbers, negative powers, even though they mean something else, but if we were multiplying same base, we still work out with the same manner. For example, 12 to the power of 15 multiplied by 12 to the power of minus 6 will become 12 to the power of 15 plus minus 6. Remember that positive and negative is a negative, so that's 15 minus 6, so that's 12 to the power of 9. So here we have the first law. The first law, again, I'm going to repeat, which states that multiplying numbers with same base, we add the powers. Second law. Second law states the following. When dividing this time, when dividing numbers with same base, we subtract the powers. Again, as in the other example, dividing numbers with same base, we have to subtract powers. Okay, so those are the two things which we need to remember. Let's see a couple of examples. For example, 8 to the power of 5 divided by 8 to the power of 3 becomes 8 to the power of 5 minus 3, which is 8 to the power of 2. Another example, x to the power of 15 divided by x to the power of 9 becomes x power 15 minus 9, which becomes x to the power of 6. Again, we can have numbers, indices which are variables. A to the power of m divided by a to the power of n, same base a, and we subtract the power m minus n. We can have even negative powers, like 13 to the power of 14 divided by 13 to the power of minus 7 becomes 13 to the power of 14 minus 7, which is 14 plus 7, which is 21. So here we've seen that, I'm going to repeat, dividing numbers with same base, important same base, okay? We could not work out if we had, for example, 8/5 divided by 7 power 3, okay? In that case, we have to evaluate each number and then divide, and then subtract powers. Law 2. Let's see law 3. Law number 3 states that any number raised to the power of 0 is 1. There is only one exception. I'm going to name that exception in a few moments. So what do we need to remember in this? Power of 0 is 1. Power of 0 is 1. So this is very important. For example, 13 to the power of 0 is 1. 1000 to the power of 0 is 1. X to the power of 0 is 1. Anything to the power of 0 is 1. Why is this so? What does power of 0 means? Well, power of 0, this is an important piece of information. Power of 0 means that we are dividing the number by itself. And when we divide the number by itself, the answer, of course, is always 1. So if I have 5 power 0, that means I am dividing 5 by 5. And dividing 5 by 5 is 1. So what is the exception? The only exception is 0 to the power of 0. Because if you divide 0 by 0, there is no result. All right? That's what we call a mathematical error. All right? We cannot divide by 0. So this is not equal to 1. All right? It has no answer. We cannot divide by 0. So that's very important. You should be able to remember that. So let me explain again. Okay, any number raised to the power of 0 is 1. Very important. That's law number 3. Law number 4. Law number 4 states that power of a power means we have to multiply the powers. So if I have 3 to the power of 4 to the power of 5, this means 3 to the power of 4 multiplied by 5, which is 3 to the power of 20. So what's important here, if we have power of a power, we need to multiply the powers, okay? So again, let's see other examples. If I have x to the power of 7 to the power of 2, this means x to the power of 7 multiplied by 2, which is x to the power of 14. If I have a to the power of m to the power of n, that means a to the power of m times n, and that is the result. We can have here negative powers, we can have fractional powers. For example, 25 to the power of 5 to the power of 1/5. This means 25 to the power of 5 times 1/5. 5 times 1/5 is 1, so that's 25 to the power of 1. Another example, 3 to the power of minus 2 to the power of 6. That's 3 to the power of minus 2 times 6, which gives 3 to the power of minus 12, negative 12. So this is our fourth law. Let me remind you, power of a power means multiply powers. Law number 5. Law number 5 is the law of negative powers, which states that a number raised to a negative power is a reciprocal. A reciprocal is a fraction. A very important fraction. Fraction 1 on something. So this means if I have 5 to the power of minus 1, the negative is a reciprocal. So the negative is 1 on. So that's 1 on 5 to the power of 1, which is 1/5. If I have 3 to the power of minus 2, for example, the negative power is 1 on. So that's 1 on 3 to the power of 2. And 1 on 3 to the power of 2 is 1/9. So if I have x to the power of minus 4, that means 1 on x to the power of 4. And if I have a to the power of minus m, that means 1 on a to the power of m. So that is the negative power. But we have to be slightly careful if our number, our base, is a fraction. So let's see another few examples where this time we have fractions. So, for example, if I have 2/3 to the power of minus 1, so the negative power is a reciprocal, but the reciprocal of the fraction, the reciprocal of 2/3 is 3 on 2. So that becomes 3 on 2 to the power of 1. Let's see another example. 2/5 to the power of minus 2, for example. So, first we take out that negative power, that's a reciprocal. So this negative power is a reciprocal of the fraction, and the reciprocal of the fraction is 5 on 2 to the power of 2, which is 5 to the power of 2 divided by 2 to the power of 2, which is 25 on 4, which is equal to 6 1/4. What happens if our number is a decimal? So let's say I have 0.04 to the power of minus 3. That means 4 on 100, because 0.04 is 4 on 100. So the first step, and you have to be very careful to this, in the first step, change the decimal to a fraction. So that is the first step. Second step, do the reciprocal. So the negative power is the reciprocal of the fraction, which is 100 on 4 to the power of 3. Now you can divide that fraction or continue working. 100 divided by 4 in this case divides exactly, so that's 25 to the power of 3. I could have also first worked out 100 cubed, 4 cubed, divided, and I would still get the same result. So pay attention, alright? If you have a decimal, in the first step, you need to change that decimal into a fraction. And that's law number 5. Those of you who are sitting for paper B, these are the 5 index laws which you need to know and which you need to know how to apply. Okay, so you have to learn this here, and you have to learn how to work out the examples. Now, for paper A students, there is another law, which is law 6. Law number 6 is called the law of fractional powers, which state that if the index is a fraction in the form P on Q, it means that P is a power and Q is a root. Now let me explain by giving a few examples. So if I have 4 to the power of 1/2, this means that I have a base of 4. 1/2, 1 is P, so 1 is the power, and 2 is the root. So that is 4 to the power of 1 and square root. The square root of 4, which is 2. It was an easy example. Let's do some other examples. Let's say that we have 343 to the power of 2/3. So that's 343, that's the base. 2 is the power, and 3 is the root. So it's the cube root of 343 squared. If you remember well, in other lessons I had told you that it's important to learn the first 10 cubic numbers. In this case, it's ideal situation because 343 is the cube of 7. So the cube root of 343 is 7. So that's 7 squared, which is equal to 49. Sometimes we're going to meet with decimal numbers. So if I have, for example, 0.16 to the power of 3 on 2. So I have, similar to the example before, 2 log 5, if I have a decimal, I have to change the decimal to a fraction first. So this becomes 16 on 100 to the power of 3 on 2. So this means that I have 16 on 100 power of 3 and square root. So I have the square root of 16 on 100 to the power of 3. The square root of 16 is 4. The square root of 100 is 10 to the power of 3, which is 4 cubed on 10 cubed, or 64 on 1000, and that can be further simplified, all right, to get 8 dividing by 8, I get 8 on 125, and that is the final result. If the answer needs to be in decimal form, use this. So the answer in that case would be 0.064. Right? So if the answer is needed to be a decimal point, use this method. If the answer needs to be a fraction, use that method. Now, sometimes we might have some simple problems which we need to solve on indices. I'm going to work out a few examples. I'm going to show you a few examples on how to use indices. So using indices. So suppose I have to work out, I have to show all your working. Work out, showing all working. Number 1. 5 to the power of x is equal to 1 on 125. Now, we have 5 power x, we have 1 on 125. First thing I need to do is change that 125 into a number with base 5. And I know that 5 cubed is 1 to 5. So that's 1 on 5 to the power of 3. But 1 on something is a reciprocal that came from a negative power. So that's 5 to the power of minus 3. So I can say that x is equal to minus negative 3. First example. Second example. Simplify. Zero point zero zero 2 5 to the power of minus 3 on 2. So I have this problem. I need to solve it. First of all, I have a decimal number, and here I have two different indices. The negative, which is the reciprocal, and the fractional. So, first step, change the decimal to a fraction, so that's 25 on 10,000 to the power of minus 3 on 2. Now, first index was the negative, so we're going to change that. Negative means inverse fraction, so I have 10,000 on 25 to the power of 3 on 2. Now we have the fractional power, which means this is 10,000 on 25 to the power of 3 square root. Now, square root of 10,000 is that number which, when multiplied by itself, gives 10,000, that's 100. Square root of 25 is 5 to the power of 3, which means that's 20 cubed, or 20 times 20 times 20, which gives 8,000. Sometimes we have to solve indices. So let's say solve 5 to the power of x is equal to 25 to the power of x minus 3. I need to solve this index equation. Now, the mathematics needed to solve that immediately is logarithms. That's an A level, so we're going to find another way out. The other way out is this. I can notice that 25 can be easily written as a base of 5. So I have 5 to the power of x is 5 squared to the power of x minus 3. But we know that power of a power means I have to multiply powers. So this is 5 power x is equal to 5 to the power of 2x minus 6. Now, since I have same base, that means that the powers are equal. So x is equal to 2x minus 6. That's now an equation. Rearranging that equation, I get x is equal to 6. So I have solved and found the value of x. These are indices. So it's important to learn them. That's the end of our lesson for today. Have a nice day.